Okay, guys, so let's go over lesson 3.1. So I'm just going to be working through these equations. Just, again, follow the steps and you should be able to solve yours. So first thing I'm going to get rid of is this number here after the parentheses. So I'm going to subtract 5 here. Because, again, my goal is to get that x by itself. So then I have 3 times x plus 1 squared equals 75. Okay, so then after that, I want to get rid of this 3 in the front. So I want to divide both sides by 3. X plus 1 squared now equals 25. And now, since I have just a factor squared here, or parentheses squared, I'm going to square both sides. Okay. So then I get x plus 1, and what happens when you square that? The square goes, or square rooted, sorry, I didn't mean to say square. And then you have to always remember that when you square root a number, that you will have 2 different solutions. So I have to put plus and minus 5. Okay, so now I'm going to subtract 1 from both sides. And now I have x equals -1 plus and minus 5, because I'm going to get 2 different solutions. First, I'm going to do -1 plus 5, that's 4. And then I'm going to do -1 minus 5, that's -6. So that would be my 2 solutions for this case. Okay, this one, again, always you take a similar approach. You start with the numbers on the outside of the parentheses, the ones that are being added first, and you kind of do the reverse of PEMDAS, basically. So PEMDAS, you would start with parentheses, then you would multiply, then you would add, right? When you solve equations, you go backwards. So here I start with adding, then I look at the number that's being multiplied and divide it, okay? So if it's added, I subtract it. If it's multiplied, I divide it. Here, I don't have anything else outside except that 7. It's being multiplied, so I'm going to divide that. Sorry, I said the 5 because I'm looking at this problem. So I divide 5 both sides, and so now we have m square root of n plus 2 minus 4 equals 3. And now outside the square root, I've got this 4, so I'm going to add that to both sides. That goes away. And now I've got the square root of n plus 2 equals 7. Okay, well, I want to get rid of the square root. So kind of like here, if I had a square, I square root it to get rid of the square, right? But if I have a square root, I do the opposite. I square both sides this time. And when I square both sides, it gets rid of the radical. And so basically now I have n plus 2 equals 49. Last step, subtract 2, and m equals 47. Okay, now on this next one, I want to get rid of the fractions. So what I want to do is look at the 2, look at the 5, look at the 10, and say, what number will all of these divide into? 2, 5, and 10. Because that's what I want to multiply. So what I'm going to do is I'm going to multiply 10, because 2 divides into 10, 5 divides into 10, and 10 divides into itself. So multiply it here and here. Now remember, as long as it has the same denominator, they just cancel out. So I just have 7x plus 3 here. And then over here, I have 10x, remember multiply it times the top, over 2, and then 10x over 5. And let's just simplify that. So 10 divided by 2 is 5x. And then 10x divided by 5 is 2x. And now you can see it's a lot easier equation to solve. On the left side, I have 2 terms that are like terms, so I can add those together. That's 7x. And then over here, 7x plus 3. And we want to get that 7 on this side of the equation, or the 7x, so let's subtract that from both sides. And then notice what happens. If I subtract 7x, I end up with 0. And so it's 0 equals 3. So if you end up with no more variables, they basically all cancel out, and you just have 2 numbers that are not equal to each other, so in this case they're not equal, there is no solution to this problem. If you were to end up with, say, something like 0 equals 0 or 3 equals 3, that is all real numbers. That would be your solution. Okay? So again, if they're equal, all real numbers, but if they're not equal, no solution. Okay, same approach over here. We're going to deal with the rational or the fraction last, so we'll get rid of that by adding that to both sides. Okay, so 6 plus 5, 11. All right, now we're going to get rid of the denominator by multiplying 4 to both sides. Okay, so remember, you multiply the same denominator, multiply number times its denominator, it cancels. So then I just get 3x plus 11. And then 4 times 11 is 44. Okay, now I just solve for it, and I take away the 11. I end up at 33, and 3x here. Divide by 3, and I get x equals 11. Okay. Okay, so now here, again, the radical is kind of like my parentheses, so I deal with that last. I've been multiplying this -2 and adding this 3, so let's start with the 3. So subtract that from both sides. You get -8. And so now over here we still have -2 times the square root of 3x plus 4. Okay, now I want to get rid of that 2. So -2 divided by both sides. And by the way, if I try to divide by -2, the problem with that is that I'm going to have to divide this 3 by -2. And then I'm going to end up with 3/2. And I don't want to do that. So that's why I start with the number that's being added or subtracted first and then divide that. So same thing here, I would start with that 10 and then divide the 2. Okay, so now here we have 3x plus 4 equals -8 divided by -2, which is +4. And now, just like those square root problems from before, to get rid of the square root, we're going to square it. I'm going to square both sides. That gets rid of the square root. It cancels it out. But on the right, it's not 4 times 2, it's 4 squared. So 4 times 4 is 16. So then -4 both sides. And then we end up with, go up here, 3x equals 12. And then divide by 3, and x equals 4. Okay. Now notice here it says, be sure to check your solutions. So with these, we want to check our solutions, and the way we're going to do that is using decimals. So basically what I'm going to do is I'm going to take this solution and plug it right into the equation. So let's type that out. Okay, so -2, I'm sorry, I was pointing to the wrong equation. The newer equation, one I just made. So 3x plus 4. So I'm just going to type out the equation first. Plus 3. Now remember I said that this is equal to -5. So after I plug it in, this should all equal -5. I'm going to plug in parentheses 4, close the parentheses, and you see that it equals -5. So we're good. So that's a good solution. Okay, so now this one, same approach, except now we have absolute value bars instead of the square root. One step is a little different here towards the end, but first, let's get rid of the numbers on the outside. Add that to both sides. We get 12 here. And now we have 3 times the absolute value of 2x plus 5. And now we get rid of the 3. Divide that from both sides. And now we have the absolute value of 2x plus 5 equals 4. So now once you have the absolute value by itself, now we're going to split this up. So this is a special method that is just for absolute value. So first, I write 2x plus 5 over here, and over here I'm going to write the same thing, 2x plus 5. So whatever's on the left, I just copy that down. Whatever's on the right, I write it down for the first equation, but for the second equation, I basically make whatever is over here the opposite sign. So it's -4. And now I just solve it twice. So now -5, -5, I get 2x equals, what is that, -1. And if I divide 2 both sides, I get x equals -1 over 2. Sorry, I'm running out of room there. And then here, I'm going to do the same thing, -5, -5. 2x equals -9. And then divide by 2. So x equals -9 over 2. So now I want to plug that back into the equation just like I did before, and I'm going to make sure it equals 8 when I plug it in. Okay, so now over here, I'm going to do 3 times the absolute value of 2 times -1 over 2. Oops, Make sure that parentheses goes outside the fraction like that. Okay, then plus 5. I'm going to basically click over to get outside that bar because the next number is minus 4. And you can see it does equal -8. Now all I got to do is just erase that fraction and delete it, and then type the next one, which is -9. And you can see they both equal 8, so they're both good solutions. So I would say yes, they're good. Now, if one of them didn't, then I would cross it out and I only have one solution. Okay, so on this one, again, we want to get that radical by itself, and instead of there being a number this time, now it's an x. So like up here, it was like +3, or here it's -4, but it's still the same steps. We're still going to basically carry that x to the other side because we want to get the radical by itself. I know we always say we want x by itself, but because we have a radical or because we have absolute value or something like that, we want to get that on the other side. Okay, so we're going to add x to this side. Okay, and now we have x minus 3 equals x minus 5. All right, so now when we have a radical, still very similar steps, we still want to square both sides. So we're going to square this side and this side. When you square this side, you end up with just x minus 3. Now you need to remember that when you square x minus 5 or two numbers together, you are basically saying that you're going to do x minus 5 twice. So that's not just like x squared and minus 5 squared. Okay, you actually need to multiply this out, which means we're going to have to do the box. Now you might notice I kind of erased things because I had to redo the problem because it didn't work quite the way I wanted the first time. Okay, so then here I get x and minus 5, x and minus 5. Okay, so I'm going to multiply. Remember, to multiply, you got to work on the outside of the box, outside the inside. That's x squared, that's -5x, that's also -5x, and then -5 times -5 is positive 25. Okay, so over here, I still have x minus 3. Here I have x squared, that's this term, and then I add up these two, that's the like terms, and it's -10x, and then plus 25. Okay, so now here's the key thing. Looking at this square root problem or radical problem compared to this one, after I squared it, I ended up with just a 3x and then some constants or numbers. Whereas here, after I squared it and multiplied it out, I ended up with an x squared term. Whenever you end up with x squared in your equation, this goes back to solving quadratics. So that means we need to get it equal to 0. So basically what I want to do is take away this x and this 3 from both sides. So here I'll subtract x and then add the 3. Okay, so then I get 0 here. And then we have x squared minus 11x and then plus 28x. Okay, so now what we want to do here is use the x in the box to be able to factor that out. When we have quadratics, we got to factor. So here we'll have 28x squared, and the bottom will have -11x. Two numbers that multiply to 28, but then also add up to -11. Okay, that would be -7x and -4x. Okay, because -7 times -7 is 28, but -7 plus -4 is -11. Okay, and remember, as like I said before, if you have just a 1 here, or there's no number really written, then you can go straight to the factors. So basically, here I'm going to have x minus 7, and here x minus 4. And so we'll have x equals 7 and x equals 4. Now here's the thing, you're not done. You've got to be sure to check your solution. So what we need to do with each of these is plug it back into the equation. So what I'm going to do is take decimals and plug in 7 and 4. So let me first type out the equation. I'm sorry, not equal to -8. We want to equal to -5 because we're using a different equation there. Okay, so we're going to type out the square root of x minus 3. I just want to first type it out with everything. Make sure I get it right. Remember, it's equal to -5. Okay, but when you type in decimals, don't type the equals. Okay, we just need to remember that it's equal to -5. So in there, to the x, I'm going to first plug in 7, because that was my first answer. And you can see it does equal -5. So that one's good. So now let's plug in the 4 that I got and see if we get the same thing. Okay, now notice here I plug in 4 and I end up with -3. That's not the right answer. So in that case, the 4 is no good. And I only have one answer, x equals 7. And that's what an extraneous solution is. So if you look at the title, an extraneous solution is something, I don't know, extra. It doesn't work. All right, so every time you do these, you got to plug those back in. Okay, so now in this one, same approach. I'm going to add the x to both sides. Okay, so now I have square root of 4x minus 4 equals x. Same thing, square both sides. Except this time, since it's just x by itself, it's just x squared. And then here we have 4x minus 4. And so again, I still have an x squared, so I'm going to want to make it equal to 0. So subtract 4x here, add 4 there. And I'll basically just do the same thing on the other side. So subtract 4x and add 4. And now it's equal to 0. Okay, so now it's equal to 0. I can do the x, 4x squared on top, negative 4x on the bottom. Put two numbers multiplied into 4x squared, add up to negative 4x, so it would be negative 2x and negative 2x. And again, since that first number, like I told you, is 1, I don't need to do the box in this case. So we get x minus 2 and x minus 2 again. Now, they're the same, right? So that means that there's only one solution, because they would be the same. For x minus 2 it would be 2, and for x minus 2 it would be 2. So I only need to go plug in this one solution. So hopefully it works, because if it doesn't, there would be no solution. So now let's type up that equation, the new one. Okay, so that's the new equation, right? And remember, it needs to equal 0 in this case. All right, so here I'm going to have to multiply the 2. And here it has to be 2. You notice it does equal 0, so that solution is good to go. Okay? All right, side. Okay, so at the top here, okay, again, I work with outside the parentheses first. So here, minus 4. And don't forget that there is a negative there. So I'm going to keep that negative in front. That 4 does not go to, that negative does not go to the 4, because it's on the right side. It would be negative 4 if that negative was over here, but it's on the right. Okay, so then minus 4, and then we have a 5 there. So now you got to remember that negative is actually a negative 1. So I want to get rid of that negative 1 by dividing it on both sides. Okay, so here 1 over 3x minus 4 equals negative 5. Okay, so now I add 4 to both sides. Okay, so now I'm going to bring this up here. Okay, so now we end up with 1 over 3x equals negative 1. Okay, then the last step I want to do here is that this, all I need to do is multiply this times the denominator. Those cancel, and I end up with 1x, or just x basically. And then here's 3 times negative 1, which is negative 3. Okay. All right, so the next one, again, outside the parentheses, look up there. First, I got a 3, so I divide that both sides. And then I end up with radical, or square root of x plus 1 plus 2 equals 3. Now I've got a radical to deal with this time. First it was parentheses, now I got a radical, and outside of the radical I have this plus 2, so subtract that from both sides. And remember what you do with the radical? You just square both sides. So when you square that, it just becomes x plus 2. And then 1 squared is 1. Subtract 2 from both sides, and then x equals negative 1. Okay, so here we're going to do minus 8 on both sides. So then we end up with negative 3x over 4 plus x equals negative 7. Okay, again, that's very similar to this one, right? You got this number in the front. It's not negative. It just happens to be that it's 8 minus this whole thing. So we got, this is really a negative 1. So the same thing like before. Divide both negative 1 on both sides. And then we get 3x over 4 plus x equals positive 7, because it's negative 7 divided by negative 1. Okay, so now, again, I've got a fraction. So remember, when you got a fraction in your problem, you want to multiply. So I'll multiply that denominator to every term. Okay, so remember, when you multiply a number that's the same as the denominator, they just cancel. So really, we just end up with 3x. And then 4 times x is 4x. And then 4 times 7 is 28. Now notice here that these are both like terms. They both have x, so we're going to add those. So let's get from 7x equals 28, and then we just divide by 7. And that equals 4. Okay. Now this one, got a number in the front of the parentheses, so let's work on that. So remember, it's negative 2 times all of that, so we're going to divide it. Since it's in the front, it's not like minus or plus, right? So we divide it. So then we have 4x minus 5 cubed, and then negative 54 divided by negative 2 is positive 27. Now, if you go back to the problem that we did on the front page, let's see, where was it? Okay, the number like this one, the very first one. We had x plus 1 squared. And what we did to get rid of that is that we square rooted it. Okay? And when remember that we say square root, right? Because there's actually a 2 right there. We just never write it. So when this equation is, sorry, wrong one. When it's cubed, we're going to do what's called a cube root. Okay, so it's kind of like square root, but it's cube root. So I'm going to cube root both sides, and that will cancel that out. So now I just have 4x minus 5. And now you do the cube root of 27. So remember, square root is one number that if you multiplied it twice, it would give you that number. But a cube root is if, what number would I multiply 3 times to get 27? Well, 3 times 3 times 3, that gives me 27, so the answer is 3. Now, the difference between a cube root and a square root is that when you square root, there's 2 possible answers. You could have a negative or a positive. But if it's a cube root or an odd root, like a 3 or a 5, then it's only one answer. Okay, so it's either going to be negative or positive, one or the other, not both. Okay, so I don't have to write plus and minus when it's a cube root. Okay, so plus 5 on both sides. 4x equals 8. Okay, then we're going to divide by 4. And then x equals 2. Okay. Okay, so now here, kind of the same approach. I've got times 2, but minus 4 on the outside. So we'll start with the minus. Added both sides. We get 50. And then 2 times y plus 3 squared. And now we're going to deal with the 2. So we'll divide that by on both sides. Okay, so now we have 25. And now, just kind of like this problem, it was a cube, but now it's a square, so we square root it. Okay, so now basically the square goes away. But now in this case, because we square root it, now we need the plus minus, because there's 2 possibilities. It could be negative 5 times negative 5 or 5 times 5. Whereas here, if I did negative 3 times negative 3 times negative 3, that would not work because that would give me negative 27, and that needs to be positive. Okay, so now I subtract the 3 from both sides. You get negative 3 plus and minus 5. So now negative 3 plus 5 is 2. And negative 3 minus 5 is negative 8. Okay. Okay, so now here we have a square root. So we square it. This goes away. 7 squared is 49 because it's 7 times 7. And then it's a simple equation. -3, both sides. And then we get 46 here, divide by 2, x equals 23. Okay, now in this one, again, I've got a rational or fraction with y on the bottom. Okay, and then I've got this number by itself. So what I'm going to do, since I got this number by itself and a like term to that number over here, let's add it to both sides. Okay, so -2 plus 4 is 2. And now we have this rational. Maybe we have something on top of another, like this. It's called a rational. And you treat it just like a fraction problem. So like here, when I divide by 4 to get rid of the 4, here I do the same thing. I basically multiply y to get rid of y. So y multiplied here, that goes away. And then I multiply y here as well. So now what you end up with is just the 3y plus 2. And then y times 2 is 2y. Okay, so now let's get the variables on one side and the numbers on the other. So here I'm going to subtract 2 from both sides, but also subtract 2y from both sides. So that cancels, that cancels. 3y minus 2y is y. And then here I subtracted 2 on this side, so then I end up with -2 over here. Okay? Okay, so now here is a cube root, very much like a square root. So because it's a cube root, instead of squaring it, now I'm going to cube both sides. So basically raise it to the power of 3. That cancels the cube root, and then I have 2 minus 3x. And I also cube this as well. Don't forget that. And remember, cube means that you are multiplying this 3 times. 1, 2, 3. 2 times 2, 4 times 2 again, 8. So don't forget that. It's not 2 times 3. It's not 6. You're going to multiply that number 3 times. Okay, so now -2 here. Just solve the equation, finish it up. Okay, then 6 here. Divide by -3, and x equals -2. Okay, here's the last couple problems here. Now, with these types of problems, when you have basically this, you need to solve for y. What we want to do here is that we can square root. We could square root this. We could square root y plus 2, but then I end up with square root of that. And there's not much I can do with square root of 8y minus 2. So the best thing to do is just expand this out. So here, let's write y plus 2 times y plus 2. And with it, basically, I know that because I see the square here, it's going to be a quadratic, so I'm going to end up making everything equal to 0. Okay, so if I did the box with y plus 2 and y plus 2, I basically would end up with y squared plus 4y plus 4. And over here, 8y minus 2. Okay, so now let's get it equal to 0 because I have a quadratic. So minus 8y here, and then plus 2 here. Okay, so now here, we'll have minus 4y, and then plus 6 equals 0. All right, so now what I want to do is try to factor that. Try to use zero product property, see if that works. If it doesn't, then we gotta do something else. Okay, so now here we do the x. 6y squared goes on top, negative 4y goes on the bottom. I'm sitting here trying to figure out what two numbers multiply to 6 but add up to -4, and nothing does. So that means I got to resort to quadratic formula. So I'm going to set up the quadratic formula. So first negative b, so negative times -4, plus and minus the square root of -4 squared minus 4 times a, which is 1, times c, which is 6, all of that over 2 times your a, which is 1. Okay, so what I'm going to do is I'm actually going to try to use Desmos to plug all this in. So that whole thing I just wrote out, let's just try to use Desmos to work it out. So I do the fraction, I do negative times -4, and then we do plus in one case, and then square root in the next case. So -4 squared minus 4 times 1 times 6. Okay, all that over 2 times 1. Now notice it says undefined. That's an issue. So why did it do that? Well, the reason it did that is because if you look at the inside of the square root right here, if you do -4 squared, it's 16. And then -4 times 1 times 6 is -24. That means you're going to end up with a negative number, which also means imaginary number. So I'm going to have to actually do this by hand because the calculator cannot do that for me. Okay, so let's bring this up. Actually, let's work out one step. So we'll do negative times negative, that's +4. And then on the inside here, we have 16 minus 24. So it ends up being the square root of -8, all over 2 times 1, 2. Okay, so now remember when you have a negative square root, you basically write it as, I put the I in front, and then you could take away the negative, and then I have 2 in the bottom. Okay, so now the next thing I want to do is I want to simplify that radical. So over here, I'm going to do the birthday cake. So divide by 2, you get 4. Divide by 2 again, you get 2, and then divide by 2. And remember, I need a group of 2, right? So I circle that group, and that's what's going to go on the outside. So I take one of those 2s, goes in the front with the I, and I only have the 2 left. So inside, I write that 2. Okay, all of that over 2. Okay, so now I need to split this up into 2 different parts because it's a complex number. So first I put the 4 over the 2, and then I put 2i times square root of 2 over 2 as well. So now I can simplify that. So now 4 divided by 2 is 2, plus and minus. 2 over 2, those basically just cancel and go away. And I'm left with I times square root of 2. So that's my solution. Okay. Now, here's the deal. You can plug all of this in and actually figure out the solution because Desmos won't do that for you. So in other words, to be able to check that solution, I'm going to have to do some work that's honestly a bit challenging because I can't just plug in a complex number or imaginary number into Desmos. So I'm going to use this equation and plug that into it to check it. So let me show you how to do that. It takes a little time. It is doable, but it can be a bit of a challenge, okay? And we'll be honest. So take my equation. Remember, I'm going to be plugging in this solution. Sorry, that. So 2 plus and minus I square root of 2. That's what I'm going to plug in here and there. So here, I'm going to plug in 2. Now remember, I have to do this twice. I got to do plus first. So 2 plus I square root of 2, and then plus 2. And then over here, 8 times the solution, the positive version, I square root of 2, and then minus 2. Okay, so over here, let's start with this. So here I have 2 like terms inside of there, a 2 and a 2. So let's add those together and get 4. And then so it's 4 plus I square root of 2 squared. And then over here, let's distribute that 8. So we get 8 times 2, which is 16. Okay, and then times 8, that would be 8i square root of 2, and then all that minus 2. Now over here on the right, again, I have like terms, so 16 minus 2 is 14, plus 8i square root of 2. Now what I got to do is this is this whole thing's squared, so I actually got to repeat this twice. Okay, and the way I multiply that out is I use the box. So I'm going to show you how to do that with imaginary numbers. So again, I'm going to write 4 in I square root of 2, and then 4 in I square root of 2. So I got to work all this out. So 4 times 4, 16. 4 times 4, I square root of 2. You just basically put the 4 in the front. Same thing here, because that's pretty much you're doing the same exact same thing. Now, when you do I square root of 2 times I square root of 2, you can show you how to do that. So basically, I'm multiplying all these different things. I'm doing I times this, times this, times this. When you multiply I times I, that's I squared. When you do square root of 2 times square root of 2, that's just 2. If you guys remember, I squared is equal to negative 1. So you end up with negative 1 times 2. So negative 2. So now here, in this case, when you use the box, these two are like numbers, and these two are like terms. So 16 minus 2, that's going to be 8. You can see, all right? And then here, I'm going to have, nope, sorry, it's not 8. Sorry, 16 minus, I was thinking 16 divided 2. 16 minus 2 is 14. Okay, that's good, because we got that there. And then 4i plus 4i is 8i, and then we just put the right 2 after it. Because you only add up the part on the outside, not the I or the square root. You can see they end up being the same thing. Not that fun, but there is a way to check if you like really want to check those answers, okay? You're going to have to take my word for it that when I plug in the other version with the negative, that it's going to give you the right answer, all right? Let's just finish up the last problem here. Okay, so now, again, we've got an absolute value problem. Now, normally, if I've got a y over here, I want that y on this side, but kind of the same reasons why we didn't bring it over is that it just makes it more complicated, to be honest. All right, and what we want is we want that absolute value by itself, and we already have that. We already have this absolute value kind of isolated. So we're going to split it right off the bat. So first, we're going to have y plus 2. Basically going to just, the first time, you just copy the equation the way it is, okay, without the bars. The second time, what you're going to do is copy the left side, but then the right, the sign switch. So if that's positive 3, that becomes negative 3. That's positive 5, that becomes negative 5. So basically what you're doing is you're multiplying this whole side times negative 1. That's really what you're doing to get this. Okay, so now I just solve it. So here I subtract 2, but also subtract 3y. So that's gone, and that's gone. Y minus 3y is negative 2y. And then 5 minus 2 is 3. And then if I divide both sides by negative 2, I get y equals negative 3 over 2. And then same thing here, minus 2, but this time plus 3y, since they're now negative. These still go away, but now it's 1 plus 3y, which is 4y. And then negative 5 minus 2, which is negative 7. Divide both sides by 4. And y equals negative 7 over 4. And now I can use decimals here. Okay, so what I'm going to do is I'm going to figure out what's the absolute value of y minus 3 with this number, and then do 2 times that number minus 10 on the other side separately on decimals. Okay, so I'm going to go decimals to show you what I mean. So basically I'm going to do like one side of the equation at a time. I'm going to do, so if I was to do y minus, what is it? Oh, gotta be careful. It's actually y plus 2. I'm going to look at the right equation here. Okay, so y plus 2, that's the left side. So basically I'm going to take my first answer, which is negative 3 over 2, and just plug that in. So negative 3 divided by 2, and I get 0.5, okay? If I click enter, if I go to the right here and click enter, it actually gives me a new line. That way I can like compare my answers. Okay, so now on the left side, it's 3y plus 5. So what I'm going to do is 3 times that same answer, negative 3 over 2, and then that plus 5. And you can see that I get the same thing. Okay, so now I'm actually going to just copy this because I'm going to do the same thing with the other answer and just type it in place. So here it was negative 7 over 4. So now I do negative 7, 7, and bottom 4. Okay. And then I'm going to do the same thing with the right side of the equation and make sure they're equal. So I do negative 7 here, 4 on the bottom there. And notice how, these two were the same on both sides, but these were not. So what that means is that negative 7 over 4 answer does not work. It is an extraneous solution, and my only solution I have is negative 3 over 2. So make sure if it asks you to check your solutions, make sure you are checking them. Honestly, it's understandable if you don't check this one because it is a complex solution, and I get that. That's pretty difficult to deal with. And you can't even really graph it. That would even be hard as well. One thing, yeah, so it's tough to check. Okay. So, but if you have like just regular solutions that are real numbers, definitely